Hello there folks, so once again we've got something blue on the bench. I thought we were going to have a Maxcom Maxon 2000 CPT set, but when I started to go into the box of 3 sets from our mystery benefactor Alan, these are repairs, so these will go back to him via an intermediary. The first set out of the box is a very smart looking Midland 2001. November 1981. So I have exactly 9 minutes to make a start, so I thought we'll make a start. I'm going to start by opening it up, and then we'll jot down some of the parameters it's doing. I've also had a parcel today from Thunderpole. Now, as you know, they provided the T3000. I some time ago, for quite a time, I said the only new radio that I would have in the car was the Thunderbolt T3000. Lo and behold, they sent one gratis, and that's what we use in the test vehicle. We've had looked at Thunderbolt 3000 before, and that's why I had to come out with that statement. We've seen quite a few, and we get on with that very well. But they also sent us to evaluate and to keep a T800. They wanted me to look at it because it was a no adjustment set. So how it's manufactured in the factory is how it is, full stop. There are no adjustments, there's no hidden menus, that's it. And we actually found it was pretty close to being spot on. So I've had a parcel today. I can feel 2 items in it. Now, I don't open the mail here, so when Mr. Chippy arrives, if I've been listening to those gramophone records, getting a new CB radio is a blessed event. So I think there's going to be a blessed event, because I certainly haven't ordered anything from Thunderpole, so well done them. So I'll let you know, because by the time I've gone into this, we're going to have opened that parcel before I finish this. The 29th of November 2023, Midland 2001. Just do the serial number. 002201. This is going to be quite early production, so it hasn't got the preset, so chances are it's going to have an unadjustable meter, and I think that's fine because that's how it is. What we don't want to do is modify every set so they all have adjustable meters, and then we've lost that diversity. We don't want everything to be the same. As production changes, and it's usually somewhere reasonably sensible, like 50 microvolts or something. Right, we'll get this. Got a nice power lead. I may as well just plug it straight into the power supply rather than going through the infamous crocodile clips. It's got 4mm plugs on the end of it. We'll go straight on to 13.8 volts, and there we go. I think it says it needs a meter lamp. Yeah. So on channel 20, and that's an ideal place to start. Let's put picture in picture on and have a quick rummage through these parameters. Test set's been on for about 90 minutes, so it's at proper operating temperature. Are we ready? We are ready. We're on the 3-watt scale. Do these sets have PA? Yes, they do. So we'll plug the speaker into... Hello. Well, I'll put the PA speaker in there, and then we'll put the test equipment speaker into the extension speaker socket, and straight away we can hear some kind of receive. Right, transmit. Here we go. And it's gone just beyond the 3 watts. And it is in fact 3 watts. 3.0 something. So channel 40, but TX light actually works, and it is 2.2 watts. No, it's not, it's 3 again. Can't read. And channel 1 is 3 watts. Transmit frequency. Let's put the inset picture on the frequency counter. And key up. Wow, it's a bit low, but it's not illegally low. So I'll tell you what, we're going to start by pulling that up. So it's 2779073. They don't have low power, which is a bit naughty, but they don't. 2779073. So just do that and hope it comes up to spec. How about that? 2779125. We're not going to do in the VCO. Deviation. Wallow. Oh, we have no transmitted audio now. We'll go over to our standard test mic. Wallow. So it's the mic which is playing up. I'm not showing you the right meter. Wallow. Now I've got 1.8. So what I'm going to do is we'll just pop this on the test set behind me. Wow, it's a little bit low. It's 2.2 peak, so we want it to be 2.2 to 2.5. So we'll deal with that immediately. Wow, that's now 2.5 peak. So go back onto the Marconi meter. So you could do with some capacitors changing in that, but whilst we've got 6 test sets, I may as well just plug into the one behind. Wow, you see, he's reading right, and there I am blaming it. So, it was 1.8 to 2.2, and now it's 2.2 to 2.5 kilohertz. So that's now fixed. And we'll look at his mic right at the end. So let's see what the meter reads. So when we key it up, it's going to be difficult because the meter lamp needs changing. It's a bit of a swine to do. It says 4.5, but the set's only doing 3 watts. And the transmit current is 1.171, which I think for no meter lamp and 3 watts output isn't good. So I'll tell you what we're going to do. We're going to run through the transmitter right away. Make sure we're on the right meter. So I want these in this, you know, it's a matter of having it on channel 20 and getting these absolutely in the centre. See, that isn't in the centre. Now it is. See, that those two have been right, but not the ones. and that wasn't quite central either. So now we move on to the others. Now these radios will usually do above 3.6 watts. So I mean, it's just done 40 years doing 3 watts. Just the actual power adjustment is the final one. It's a matter of getting these peaked first. See, that's in the wrong position. We're a whisker away from 4 watts. And the final one is this, which is what, according to the service manual, this is the one you're adjusting the power with. Go into that tool instead. Doesn't feel brilliant, but then it looks like it's sealed, so that's strange. It's capable of about 4.4. So there we are at 4. Now let's go over to channel 40, and it's a whisker under 4, and channel 1 is a whisker over 4. So I'll tell you what, we're going to just see if we can improve that. I think there's a parcel coming. I can hear a car door. Right, channel 1, 4.1, channel 40, about 3.95, 4.1, 4.0, 3.95, and we've now got a current consumption of 1.038, 1.038, so we're now doing another watt, and it's drawing 100 milliamps less, so that just goes to show. So it's actually under less strain to do a watt more. So we've still got that to there. Let's see what the RF output meters now says. It actually hasn't really changed. It says 5. So we'll just pop that down a fraction. Use a smaller tool. I know what it is. They psychologically want it to bang across, don't they? Oh, look how powerful this set is. Boing, boing, boing. Good. Well, we've heard it receive, so I'm just going to quickly check. Make a start on the receive, because I know I've got to strip all this down and spend quite some time doing the meter, which will take longer than the tune-up. So we'll park the signal generator at 1 microvolt, and let's get it on frequency 27.79125. We're not actually that far out. To be honest, it's more sensitive than usual, I'm sure it is. It's 0.58. For 10, 0.54. And for 20, it's 1. Scroll, just put that to full. So I like sets to be able to squelch out or come in at S9 equivalent of 100 microvolts. So 1, 3, 10, 30, 100, 300. It's coming in at 7 millivolts, and the threshold 0.53. I mean, the threshold's fine, but it's a bit coarse at the top end. So we've done that. Let's see what the S meter says for S9. Now this is not adjustable on this set, and it's showing a 5. So S9 on this particular set is 1.5 microvolts. So very oversensitive. So I don't think this is one which is adjustable. Nope. So some sets have got a preset on the back of the meter. Some sets have a preset there, and some don't have one at all. And this is one that doesn't have one at all because it's early production. So it's always going to read a bit generous. So that doesn't work. We'll sort that out. They work. Let's check PA. Testing 1 2. Test 1 2. Absolutely fine. That's that done. Right, we'll run through the receiver. So we're going to look at the oscilloscope and see whether our detector's in the right place. Yeah, absolutely was in the right place. So we'll now put 4 dB. We've attenuated the receiver until we've got 4 dB. And then we're not saturating the receiver. See if we can gain anything. Nothing to be gained there. Ah, that's come in a bit. I'm just going to go back to the previous one. It can be interactive. The next one, probably a tiny bit there. There we go, get a new reading. Oh good, 0.49. Naught 0.45. 0.9. Let's deal with this squelch. Turn the squelch to full, and I want to adjust the preset till we hear the tone. Okay, it's there, is it? That's now 100 microvolts. And threshold position. Naught 0.42. So that's how daft. Look how daft the meter reads now. 1 microvolt, 3 microvolts, 10 microvolts. In actual fact, it's a much more sensible reading. 30 microvolts, 100 microvolts, 300 microvolts. It's now actually a bit on the... I must have read this wrong. I must have read it wrong the first time. It's now 300 microvolts. So it's on the deaf side, and that's absolutely fine because that's how it's supposed to be. What a sensitive set. That is, they're supposed to be better than 0.7, and it was already better than 0.7, and it's now even better. So I'm going to take a break, and then we'll come back and do that meter lamp. Right, well that's the meter done. Put a new lamp in that, and it's actually the right brightness. It's not supposed to glare out like a headlight. Lot of faff to get it. I said earlier, it takes as long to do that meter lamp as it does to do the tune-up. Let's get some of these screws in. This is a lovely condition set, especially considering it's 40 years old, and it works well as well. That's a good phrase, isn't it? Works well as well. It also works well. I can't see any dodginess. It doesn't matter how many times I do these. I'll do these, put these in slightly loose because the case has all got to fit together properly, obviously. Right, so we know when we switch it on, I'll put the knobs on in the right position. We know it was on channel 20. Still on channel 20. There we go. Speaker lid. So had I not had to do the meter lamp, this would have just been a retune and test, no fault. So I brought it up from 3 watts to 4 watts, brought the deviation up from a peak of 2.2 to a peak of 2.5, so it will make a bit of a difference, and we've been able to hot up the receiver a bit. I'm not sure if the meter lamp failed or whether one of the wires just corroded away with old age and poverty. So before we go any further, I'll switch it on and make sure that, I'll now move on to this mic, make sure this is actually receiving. Now that's interesting because I'd expect more of a hiss than that. So back to our Cybernet standard mic. Okay. So as you know, we don't do mic repairs, but obviously we do for for certain special people. You didn't get the posh slider arrangement on this version of the 2001. Now, where did I put the other 2 screws? Out there. I'm attacked by a mad piece of solder. And then, with any luck, we'll get an on-the-air test done. I'll move on to another. I probably said earlier, I've got 26 church services. It's actually just gone up one to 27. I don't know how I'm going to do one at 3 o'clock and one at 4 o'clock, because surely the service lasts 55 minutes and the churches are 4 miles apart, so that's going to be novel, isn't it? I wonder what the vicar's got to say about that. Perhaps I do half a service and run off. Okay, so we've obviously got a major issue with this microphone. Of course, it doesn't even put the receive through. So I'm going to open it up because it's rattling. This will probably take as long as the tune-up as well. Well, it's certainly the right insert. So if I shorted those 2 pins out, we should get receive, but we don't. So there must be something amiss. Either the cable's snapped, or there's a wire off, or it's been rewired for another type of radio. So it's standard cybernet wiring, even though these sets are made by Maxon. Now this screw's going around in circles. That makes it very difficult to get out. No, it's not going to. I can't get that out. So there's no point drilling it out. I just may as well cut the plug off and put another one on. We'll recover those screws. So we've actually only lost 3/4 of an inch of wire in there. So we've got some suitable sleeving. What I'm hoping is that the cable isn't full of water. So it's obvious, without looking at the mic head, it is obvious which wire's which. First of all, of course, you've got the braid, the screen. So we know that that is the earth braid screen, which goes to common. So we'll just twist that and put some solder on it. That's that one. And that was wrapped around this thicker black one, which is actually yellow. So that's a sleeving round the yellow wire. And that's revealed the yellow. So that's our audio, because that's the one that has to be shielded. and then we've got black and red. So chances are that, yeah, black is receive and red is transmit, just like you'd expect. How easy was that? Just get rid of that bit of tape. We'll just get a plug, and I've got some on my bench here which are new old stock. By that, what's happened is we've had to cut the plug off to put a different type of plug on, because sometimes we can only buy plugs in that come with, sorry, I'll start that again. Sometimes we can only buy mics in that already have a plug on them. Now, as it happens, I haven't found one yet. They've all been robbed for parts, which is what happens. Knights at Curtin in Lindsay sell the teeny tiny screws. I think they are listed with them as teeny weeny screws. No, I'll just have to go into a stock bin and get a new one out. I don't know where my chart is of mics, but we've got this in front. This is the circuit diagram for the Maxcom 30E yesterday, and it shows the mic unit here, and we can see that pin 1 is connected to audio. Now my jig isn't handy today, so I'm going to have to fiddle about with several fingers. Just tin all these for a start. And pin 1 they're all labelled, is that one, and the earth is two. Now we normally put some sleeving round these. Where's my sleeving? Oh, they're all thieves in this prison, I tell you. It's going to have to be a trip to Mr. Chippy's. Right, so I'm putting sleeving on there, and that's now on the second pin round. So pin 3 looks like receive. So that's going to be the black wire on the next. And then finally, pin 4 is transmit. And I haven't tinned that one. What did I do then? Or did I tin it in the wrong place? Am I losing the plot? Find out tomorrow. There we go, that's all 4 on, and I'll just plug it in and see whether that does what we expect it to do. No. One, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. We've got no audio on this, but it is keying up. I think we had that before, but we've got no receive either. There we go. It's in the mic head, about there. I was able to just pull the wire out. So what we'll do, we'll extend that bit of wire. But we still not out to the wood yet because there's no transmitted audio. And we've got the earth, so why haven't we got transmitted audio? Unbelievable. So when I did electronics training, they only test you looking for one fault. They don't, you know, right, here's a television set and it doesn't do such and such. And then, 20 minutes later with a method of diagnostics, oh yes, it's the such and such, and you replace it. But in reality, I'll just turn this set off because the soldering iron's giving it an earth bath. In reality, you've got multiple faults. And how can you have multiple faults on a mic unit? I'm just breathing in the nastiness. In actual fact, that wire's long enough to go to its pin, despite cutting an inch off it. And there's no strain there. Switch the set on. Well, we've got receive and we've got transmit. We've got no transmitted audio, so let's see what's happening there. Wallow. 1, 2, 1, 2. Let's put our monitor receiver on. We've got the TTI one today. Turn the thing down. 1, 2, 1, 2. 1, 2, 1, 2. So, have we got a duff wire? Have we got a duff mic insert? It's not the normal noise. Yeah, it's got a break. What has happened to this? You can see it's there. And we still don't know whether the mic insert works, do we? So now if I go into transmit, I'll turn my monitor off. Has it gone flat? What's happened there? Yeah, there's a snap in the red one as well. So something's happened. So we basically cut an inch off the cable inside. That was only hanging on by the skin of its teeth. So let's do the same with that. That needs, we're going to have to lengthen the yellow one. Right, so back to what I was saying. We'll switch the set back on. Going to transmit, and hopefully we can hear some finger audio over that wire. So I've just put a bit of extra wire on that. There just happens to be a bit of yellow off some horrible illegal modification that's ready to go in the bin. And there we go. So we'll put some sleeving on that. We have a hot air gun. And we have a soldering iron, and there we go. Hot air gun's not in my room. At least doing it this way, we've maintained the same colours. Some of us are really yanked hard on this. I think they've towed a car with the mic link. 1 2 1 2, testing 1 2. You know what? We've got no audio, have we? Because not only that, you see, the mic insert's knackered. Oh dear. So and you see this video edited, it's not like this is in real time. Yep, mic insert's knackered. So I don't know whether I've changed the mic plug for no reason, because I've got no proof now, have I? Now I think that I've seen some of these. We had one of these the other week, and I was clearing a drawer out, and I spotted some more. So that goes in the vertical filing cabinet, and I'll be right back. And there we go. It's the last one. I'll tell you what happened with these. In fact, we'll tell you what, we'll do it from this side. When I was at Nottingham Radio, we had quite a number of Marconi VHF AM high band business radios. So for people who don't know, we're looking at frequency band round about 100 and well, it's split. You're going to have transmit and receive split. So you're going to be looking at something like 166 transmit and 171, something like that, transmit. Did I say that right? From the mobile. 166 to 171 your split is. The split is 4.8 megs in the UK between transmit and receive. And that stops vehicles talking to each other and only talking to the base. So, these Marconi radios, the impedance of the microphone required was 300 ohms. So what we did was to buy a pile of 300 ohm inserts, and then we just bought CB type microphones you've got to bear in mind these are on rent, so we're paying for repairs. So what you don't want to do is to spend more money than you need to. And at that time, ordinary replacement CB mics were, about £4.50, something like that. So we could put the insert in, and the insert was quite a lot of money, like £12 or something like that. But it was still much, much cheaper than buying the proper Marconi mics, and then it all worked properly. So there we are. So that's gone in there. And hopefully we've got audio now. Testing 1, 2. Oh yeah. So that's the final one. So any more broken Midland mics, we don't have any factory original inserts. Now it was rattling, don't know why that was. Yeah, it's going to rattle, I don't know why it's rattling. As I said before, I think we need to just plump up this heat shrink. We need to just plump this padding up, don't we? That's far too thick. Need something half that thickness. I really don't know what we've got. That's exactly right. Bit of packing material, so somebody's going to get an inch of packing less when they get their radio back. So what was that? 30 minutes to do, 20 minutes to do the tune-up, 25 minutes to do the meter lamp, and 30 minutes to do the microphone, plus a microphone insert. Now, seeing as our mystery benefactor has sent us microphone inserts before, even though not this model, there'll be no charge. So all he's charged, the only money he'll be having to pay for this will be the service fee. So nothing for the mic plug, and that's because of what he's done. Well, we've got there. Oh, come on, get in there, you swine. So with the teeny weeny screw and the appropriate screwdriver, if this video goes over an hour, we'll edit it to its be just an hour. I think I'm putting the wrong screw in there. It's that one. Good. So we'll still do our test with the original with the usual mic, the standard one. Testing 1 2, not even on now. Testing 1 2, testing 1 2, testing 1 2. Tell you what we'll do. We'll just put this on the public address speaker and see if we can hear the difference, even though this public address speaker is only 4 feet away from me. Testing 1 2. Let's get that to that volume so we can hear that. Testing 1 2. And then we'll go to our standard replacement mic. Testing 1 2. They are crisper, those, but at least we've done that, so I'm very pleased about it. So just to conclude, I've got to put, this is Allen, and I've got to put meter, lamp, mic, plug, mic, insert. Good. So now we'll plug it into the roof aerial and switch all this test gear off. Right, let's have a flick round.
Doing about 2.5 weeks. Yeah, you can throw them all. The right build.
One on the Roger.
Yeah, got a week and a half off, I think. Well, won't be late. Won't be late now. I think it's... Always the same. If you in the sister, generally it's a bit warmer.
Who's that? One on the Roger. Okay, so we're doing on the air test. I've no doubt.
Knocking on same old door.
There we go. So we got there in the event. Eventually, nice set, and thank you for watching.